NASA has not sent a dedicated mission to our closest planetary neighbor in nearly 30 years. In 1994, the Magellan orbiter finished mapping nearly the entire surface of Venus using radar. Then, its operators intentionally crashed it into the planet's atmosphere, starting a multi-decade hiatus. Over that same exact time frame, Mars received a constant stream of attention, over a dozen dedicated orbiters and rovers. This chart compares the atmospheric pressure of Earth and Venus. At the surface, the pressure on Venus shoots up to 92 times that of Earth. Standing on the ground there is physically equivalent to being 900 meters underwater. The Soviet Venera landers proved exactly how hostile this is. Despite being heavily armored, the longest any of these probes survived was 127 minutes before being crushed and cooked. Building sensitive scientific instruments to function inside a high-pressure acid autoclave proved so difficult and so expensive that NASA simply decided going back wasn't worth the cost. Then, in 2019, a climate modeling study from NASA Goddard showed that Venus likely harbored liquid oceans and temperate conditions for up to 3 billion years. About 700 million years ago, a massive surge of carbon dioxide triggered a runaway greenhouse effect, boiling off its water and trapping the planet in a thick, toxic haze. A year after that climate model, a research team detected roughly 20 parts per billion of phosphine gas high in the Venusian clouds. On Earth, phosphine is strongly associated with biological processes. This cross-section maps the altitude of the Venusian atmosphere. Up at the 45 to 60 kilometer mark, the temperature is surprisingly temperate. But the clouds are made of concentrated sulfuric acid, rapidly corroding spacecraft materials. The phosphine claim triggered a fierce debate. Competing teams analyzed the exact same readings and argued the signal was actually a data processing artifact. This controversy exposed a limitation in the existing observation network. Without a modern probe actually in orbit, scientists had no way to confirm or deny the existence of biological markers. While the atmospheric data remained contested, a separate discovery in 2023 shifted the focus back to 30-year-old unexamined radar images from the Magellan mission. Robert Herrick compared two scans of the same location taken 8 months apart in 1991. The data clearly showed that a volcanic vent had physically expanded and changed shape between the two passes. Published in the journal Science, this became the first direct observational evidence of active volcanism on Venus. Venus is geologically alive right now. The scientific community realized they had been ignoring an active world for 30 years. That single volcanic discovery ended the hiatus. NASA and the European Space Agency quickly approved 3 simultaneous missions to go back, the orbiters Veritas and Envision, alongside a mission called Da Vinci. Da Vinci is designed to drop a specialized probe straight down through those hostile acid clouds, sampling the atmospheric chemistry on its way to the surface. This diagram tracks the probe's descent profile. Da Vinci has exactly 63 minutes to fall through the atmosphere. Every instrument must work perfectly on this single run before the probe hits the surface and the mission ends. Parallel to NASA, MIT's Sarah Seeker has developed a privately funded proposal called the Venus Life Finder. Her mission bypasses the surface entirely. It specifically targets that temperate 48 to 60 kilometer cloud layer to search for any surviving microbial life that might have somehow adapted to the extreme hostile acid environment. Sending instruments into this atmosphere remains an extreme engineering risk, but mapping how Earth's closest twin transformed into a high-pressure toxic graveyard provides the clearest window we have into the fragility of our own climate.